Okay, let's move forward. We have a presentation today. I'm going to introduce Pachama. The team from Pachama, which actually let's start with Marie Hoeger is with Pachama. I will let her introduce herself, and we also have Bernhard Stadlbauer there. I think the Pachama team has a really compelling story to tell about what Pachama is, the background, what they're doing, and how they ended up picking a orchestrator for their tasks. And so we're gonna see how they have rolled it out, what they have learned, and if there in hindsight any recommendations they can give to others. So with that, I hand over to, I assume, Marie, or do you want me to drive the presentation?
Yeah, if you can hand it over, that'd be great.
And let me just stop sharing here. And
all right. Great. Yeah, so I guess we'll be chatting today about Flyte at Pachama, and an overview of what we'll be talking about is, or I guess I should probably introduce myself first. My name is Marie. I'm a software engineering manager at Pachama on the protocol platform team. So we work a lot with the scientists and researchers and remote sensing type of world. And Bernhard.
Hello, my name is Bernhard. I'm a data engineer working with Marie, and yeah, mostly responsible or feeling responsible for putting workloads onto Flyte and scaling out a bit.
Awesome. So jumping right into the presentation, we'll talk a little bit about what is Pachama and how it relates to forest carbon credits, and then also what are forest carbon credits, because they're a little bit niche, and then business requirements that have kind of shaped our decisions around using Flyte, how we use Flyte, why we love it, and then finally kind of a development tip around registration. So the core of Pachama's mission is to remove carbon from the atmosphere and to restore nature. And that's a big, lofty goal. So how do we get there as a business? And our answer for that is forest carbon credits. So the central premise behind carbon credits is that our landscapes are shaped by market forces, and often those reflect the short-term value that can be extracted from the land. So you see on the left kind of the aerial view, but on the right as well, a forest that was chopped down for cattle grazing. But if we properly quantified the economic value that we got behind the ecological services provided by the existing landscape, we'd also see much larger value. And that's even ignoring kind of the inherent non-economic value of the life on the land and depending on the land as well. So that's kind of the idea behind carbon credits, is find a financial instrument to compensate landowners for leaving forests intact. And the most tangible economic value we get from it is carbon capture and storage, especially because climate change is the biggest all-encompassing ecological crisis facing all of us. So from this, we get the idea of the carbon credit. Let's see. Here are a couple of pictures from one of the projects that we work with. Kind of showing this is inside the project land, the mature forest as it is, versus right next door where land is being converted for soy and cattle. So the success of kind of the carbon credit premise depends on the integrity of the measurement, and we need to be able to really robustly quantify the carbon value in order to sell it as an asset, because that's how we're going to realize the environment benefit for the people purchasing the credits. So otherwise it becomes a place where bad actors can succeed. And so when we don't properly quantify the impact measured in carbon, then it can even have a net negative impact on CO2 equivalents in the atmosphere due to companies relying on the stated accuracy of a carbon credit promise. And so we definitely want to avoid that as much as we can. So existing forest carbon offsets do a best effort at this problem, but most of the existing approaches were originally formed under the IPCC guidelines from the early 2000s. So technology has advanced quite a bit since then. We have more powerful tools to face this problem, including new scientific data, new remote sensing data, flight, and access to massive amounts of compute, as well as machine learning. So kind of in a sentence, Pachama is working to harness the power of remote sensing and machine learning to increase transparency, quality, scalability in the carbon market. So we have kind of these two buckets, focusing on technology-based assessment of the quality of carbon credits and a transparent online marketplace. So within the first bucket of tech-based assessments, we work on things like an algorithmically generated impartial baseline off of which to calculate the crediting numbers, deforestation monitoring, and scaling hand-collected biomass measurements to broader areas. In the second big bucket, teams work on easy and secure purchases and showcasing quality projects. And today we'll mostly be talking about the tech-based assessments side of the business, since that's the area that Bernhard and I work on, and also where we use Flyte. So the two main problems that we work on through our Flyte workflows are biomass modeling and the baseline calculation, which are two key components that go into calculating a carbon credit. So what is a carbon credit? At Pachama, we're trying to simplify the calculation of a carbon credit and use algorithms with transparent and reasonable defaults and remote sensing all the way through. So at its core, a carbon credit should be a measurement of the change in carbon from some intervention, like establishing a carbon credit project, versus the change in carbon that would have happened without the project being established. So if it's a restoration project, we estimate how much would have naturally regrown versus how much has grown with maybe active planting or things like that. And with a conservation project, we try to estimate how much carbon is still intact versus how much would have been taken away under the status quo. So trying to figure out what would have happened is the very tricky part, and the part that often comes under the most scrutiny. We're trying to prove a counterfactual, which is very difficult. But that also doesn't mean that it's impossible, because we can use math to find good answers. And a good example of other fields that do this, because scientists don't always get to run a controlled experiment to make good conclusions. So the other example of where we see this in science is in epidemiological studies. Because we can't intentionally go out and infect people with a disease or expose them to hazards to try to learn about the impact that it has on the population. So those are examples of places where we might use a similar type of logic and math to come to conclusions about what would have happened. So when we try to answer the what if bit, a good control area is very important. Most of our current research is for the baseline is going into choosing a control area for conservation or avoided deforestation scenarios. And so what our scientists and modelers are trying to do is to find areas of land that are at a similar risk of deforestation as the land before the project gets established. So the baseline team aggregates a number of features about the land that would influence its risk factor for deforestation, and then runs an algorithm to pick the project's control area. So in that way, we get here's a reasonable estimate of what would have happened, and we can run this over many, many times to also calculate the error in that estimate. The next input is the change in carbon, and for this, we want to look at forest cover gain and loss. Primarily for deforestation, we'll look at forest cover loss and assume that carbon goes to zero if the area gets deforested. And we can see this with satellite imagery, including changes over time. So on the left is a quick video of again, a real project that shows the project area versus the surrounding areas that are getting deforested for cattle soy in this case again. And then on the right, we see kind of looking for those changes over time with satellite imagery. And the last input is carbon, since we're checking the change in carbon, and we're using remote sensing inputs and machine learning to create carbon maps for this bin. So to do all of this and meet our goals about quality, transparency, scalability, there are a few high-level business requirements when we were looking for our right compute tools. And so a couple of things that shaped our decisions were access to lots of compute, large-scale data ingest and processing, and then robust lineage. And robust lineage is in particular important for us because part of what we're trying to bring is transparency. And robust lineage is already important for just kind of experiment tracking and all that. But in addition to that, we also need to be conscious about when we might get reviewed by third parties, having all the available data to be able to go back in time and say, this is how we got this number. Another factor kind of influencing our decision is our team structure and collaboration. So we have a couple of different research teams at Pachama, and then one kind of core platform engineering team. And so a lot of those research teams have similar needs and often share the same data sources. And so we wanted to be able to build shared components across the team for data, data ETL, and other bits, while still allowing for direct ownership of the workflows by our remote sensing scientists and our machine learning modelers. And Bernhard, I'll pass it over to you.
Cool. Thank you. Let me see if I can get my screen shared here. Can you see my screen? Okay, thank you very much. I'm doing my name is Bernhard. I'm a data engineer. I think we had that before. I'm doing a bit more of a technical part, and I thought I would also share some of the things we will. Wait, Mari, could it be that you missed the slide?
Yeah, sorry, I think I skipped that one, so we could
okay.
go over it for time.
I do a bit more of a in-depth tech bit, and also a small demo of something that I think we built that is really cool. Maybe it's helpful to someone watching this, and maybe if they're starting off with Flyte, that's something they could use. Also, if someone has a better suggestion on how to do registering or whatever, happy to discuss this afterwards. So this is how we do it. We quite like it, but there might be better options. And then in the end, I do have a small section on what we had troubles with Flyte, what we struggled with, and maybe also as a feedback and conversation topic to talk about. First off, what we like about Flyte, I think the biggest thing is the community. Thank you so much. I've worked with Flyte for, it's been almost 2 years, at least 1.5, and we've gotten a lot back. We've gotten so much support. I must also say that the core, so Propeller, that scheduling work, it just works. It has, I think I've seen 1 or 2 failures maybe throughout the 1.5 years, but it's really stable. And most of the issues that we had were mostly, and we talk about this, about UX and just small little bits that are not affecting the actual compute. So that's really amazing, and thank you for everybody who helped us there. And that, like, the turnaround cycle is also really good on getting feedback. So just like community and everything. I think probably the second biggest thing that I would put there is caching. So just reducing the iteration cycle by not having to redo work is something that I found really, really valuable. It also makes debugging really easy, because if one task fails, usually it's almost a one-to-one mapping to your local workflow. And so stepping into a debugger is mostly downloading the data. For us, that's sometimes quite large, but then yeah, you can debug locally, which really helps. And the third bit is what Mario already touched on, is we get a lot of reusable workflows, and it makes it fairly easy to share complex machine learning and different dependencies between teams without actually having to put all the dependencies into one container. So if someone wants to use Torch, they can use Torch. If someone wants to use TensorFlow, we don't encourage different frameworks, but we do at least leave us the possibility. Also, we do work a lot with Dask. So we're working on a small Dask integration. We do have something in-house, but we'd also like to share that out because Dask tries to become the standard in geospatial processing with the Pangeo project. There's a lot of work going on there, and they take there's great work that we try to leverage from them. The interactive bit is, I thought I would share out how we do registering for workflows. And we rely a lot on CI/CD. So I think, and I might be wrong there, that this is not very clear in the Flyte docs. I'm not quite sure though, but I thought I'd share it out. So what we do is, when this is a git graph, on each commit to main, we automatically on CI register to production. We use some semantic versioning for this because that's how most of our projects work. I think that's quite standard. We do testing on main, so we do continuous deployment and goes to production. On each feature branch, we automatically deploy to development. So also the iteration cycle is quite quick there. And you have a version that you can refer to if you share it out with colleagues. And probably the small specialized case that we have is we really like fast registration. And the biggest issue that we've seen there is picking out the right Docker image, because you would like to have a Docker image that is as similar as you can to your current code, right? But you don't want to build the Docker image and push it, because that's the benefit. And so we wrote ourselves a small script. Guess we could also share that if someone wants that at some point. Basically, what we do is, say we are on a feature branch, we've pushed somewhere, and then we added 2 more commits, which are not pushed yet, so there's no image. In case the dependencies haven't changed or the Docker image hasn't changed, what we do is we actually traverse the Git graph and then check against the registry until we find the first image. And as soon as we find the first image, that's the image we're gonna use for registering. So we do have some small makefile magic that actually makes sure to pick the closest image to you, which has proven to be quite well valuable. That's that. We do the same. We even go back to main and whatever. Yeah. Yeah, Keithan.
This is something that I've been wanting to do. I just didn't know, and it's amazing. Can you please somehow contribute this as a blog or a doc? Because I think fast registration's biggest problem is where it breaks certain assumptions in Flyte. Like Flyte relies on reproducibility and guarantees, like, that the environment is kind of hermetic. But fast registration is a way to like break all of those promises and like, here's some code, here's a random image. And so if you can like walking the registry, I don't know if everybody may have access to that, but like if you can share how you do that, would be fantastic. Maybe there is a nicer abstraction potentially as the community we can build, so that we always prevent any kind of bugs from happening, because this does cause a lot of bugs. It can, if you don't know what you're doing, right? So no, but thank you. This is amazing. It's amazing you kind of like stole the idea from my head and put it out there. So thank you.
Yeah, I think the original idea is not, I'm actually not the original inventor of this. This is someone else, and they know. But yeah, we manage most of our projects through makefiles. We also do have a cookie cutter and the craft template that automatically, we found that we need quite a bit of boilerplate, or like a bit of boilerplate for all of our projects. And so we use cookie cutter to do that, and then craft to downstream updates. So that's something we've also seen that was quite nice.
Real quick question. I'm curious, after you traverse, how do you ensure that like the Docker file or no like requirements files have changed? Like how do you make sure that the image that would build on this current branch would be the same as?
We don't. So
Okay.
it is not, we don't ensure that. We probably could even. I think we could, yeah, because I think we could. But it has prevented, let's say, 95% of the issues that people were seeing already. Of that, and the rest was communication. So we tried to communicate out, okay, when you change your dependencies, you want to push at least once, but that being a quite the rare event, it has worked out quite well. That was it for the small practical bit that we wanted to include. maybe common issues that we were seeing, and these are focusing on the developer side. So this is not on the deployment side or anything else. So this is mostly when machine learning engineers, data engineers come to us as a platform team, what they are struggling with. And overall, they're super happy because they can now do, for example, we do grid searches on different things, and that Flyte makes that very easy. Probably the biggest thing that people struggle with, or that I've seen in the last 1.5 years, is input and output serialization. We try not to use Pickle because that has the typical Pickle problems. I think you mentioned that on your docs page as well. But then what the kind of, it's very easy if you only have simple types and if your signature is very simple, but sometimes we would like to do more complex configuration. And then that has caused some confusion. When to use a data class, when to use a named tuple, when what's serializable, why is the first output called O0, and then when you're named, there's a few things that we've seen. We also try to communicate on what's possible. The second bit that comes kind of hand in hand with this is when you have complex types, the UX is sometimes a bit hard to use. And this is continuously improving. We have recently updated our console, so it's gotten a lot better. But then people wanted to use arbitrary dicts, and people have crazy ideas. Let's put it that way. And then sometimes it's we need to work on ways around it. In general, though, we are a fan of very simple interfaces and making them serializable. So that's definitely something we are supporting. One thing we have also seen is quite often, or sometimes we have the use case where we would like to have a map task, but for a sub workflow. And what we then usually do is a dynamic task that starts the sub workflows. But when that spans out quite far, it gets really hard to track in the UX of what has happened. I think the graph view has improved dramatically. That is amazing. We use that now, but it's sometimes just tricky to see how many have completed. We built custom tooling around that, but that's maybe a feedback bit. And sometimes we have struggled a bit with errors or things when it says please contact your system administrator. This is very small. This hasn't happened very often, but every once in a while the log messages or the errors weren't perfect. But all in all, we're super happy with what's happening, and this should be more constructive than anything. Thank you very much for what you've built. I think this is also my last slide. I think so, yes.
Fantastic. That's so interesting. Okay, so let's do a quick round of Q&A. So I do have a few questions, but I want to ask the audience if there are any other questions. Keithan, you always have a question. Let you go first.
I always have a question. So I will let other people go first, then I will go next. Other people are shy, so I'm going to go take the stage. Firstly, those feedback, please, so UX is something that is very hard to do without users constantly giving feedback, right? Like it's like this. Yes, we would love to be Apple. We are not. We are not able to make the perfect UX for everybody. So please, if you have ideas like this, these are highly encouraged. Throw them in an issue or like jump into the channel and share, draw a mock or something that you would like. And it would be amazing for us to know because, and I think like some of the people who have been working on the UI side, and feel free to contribute, but in my team, people who are working on the UI side have never even seen the extremely complicated graphs, right? So they may not know how to really present them. So as a feedback to you on your feedback is please help us improve it. The second aspect is, so you mentioned scale. So what kind of a scale are you running at? How many workflows? That helps. Like just yesterday, one new user has been asking the scale, and we kind of say that Flyte is extremely reliable, and I almost hear this from everybody. Nobody's ever written a blog or anything that says like, okay, just scale it and it just works. We would love that, but in the absence of that, we would love to know, what's your scale, whatever you can share. It'd be really helpful.
Mm-hmm. Should I take it, Mario? Do you want to?
I can do like one quick message or mention about the baseline, and then I'll hand it to you. Yeah. Sorry, we meant to say this in the presentation too, but for one of our like baseline runs, because that's where there's a lot of Flyte usage right now. As an example, for each project that we evaluate, we might have hundreds of kind of KNN pixel matching runs, and hundreds to be able to estimate uncertainty. So that's like over, kind of millions of kilometers squared, doing the pixel matching. We'll have tens of features per year, and then tens of years. And then on top of that too, when we want to kind of like tune our parameters for that baseline, we would also do hundreds of those millions of hectares or kilometers. And then, yeah, Bernhard.
Yeah, I think that sums it up quite well. Some of these also start task clusters that are 50 nodes, not 50 pods in just within them, and so like things can go crazy really quickly. But that all works out really well, and I've seen it work at even crazier scales before. So I think we're not at the limit yet that I know.
Yeah, and this is all on a single cluster. Sorry, go ahead, Mary. Yeah, is it single cluster?
Yeah, it's all on a single cluster. Yeah, and I think we're not at the limit yet. Also, not any propeller limit or anything. And we do know that we want to start launch plans instead of sub workflows, and so we have looked into that a little. But so far, Flyte is not our bottleneck by any means.
Yeah, I was going to say not to hate on other platforms, but I do think Dask consistently is the area where we see like scale breaking, and it's really refreshing to just come over our Flyte workflows and be like, oh, you're still working and you're fine.
That's fantastic. So I have a question for you with regards to Maria. You mentioned it at the beginning that, and I think Bernhard too, that the team aspect played a really important aspect, reaching across the departments from the researchers to data scientists to the machine learning engineers and engineers. So can you walk us through the discovery process? I mean, who was involved? How did you make the decision 2 years ago to pick Flyte? And what were your alternatives?
Yeah, I can start with a little bit of the history, and then I'll pass it over to Bernhard, who did a lot of the actual kind of evaluation of different frameworks. But I would say before we kind of settled and chose on Flyte, there was just a lot of ad hoc code, and we were really struggling to be able to say, okay, the researchers have their own kind of like big monorepo and notebooks and other ad hoc scripts, and we were trying to use a little bit of Beam in there for some of the parallel compute, but anytime anybody wanted to do something in a similar way, they would kind of like ask around and then copy paste all that code. And so, yeah, we were just having a ton of troubles with that. And I think there were some ideas of, okay, do we want to try to, build our own thing or not? And I think we luckily kind of decided not and to look around first. So that was kind of the state of things before we went to Flyte. And Bernhard, if you want to talk a little bit about kind of how we evaluated.
Yeah, so I came into Pachama with a heavy bias of having used Flyte before, even though we still wanted to, because the problem I've worked on before was slightly different. We still evaluated different frameworks. Mostly I want to see more modern ones. So we didn't want any YAML. I think like typical things you'd find when people evaluate stuff. And we looked a lot at Prefect and Kubeflow, but in the end, a few of the key features like memoization, making sure that everything runs with the right Python versions and the right Docker image, and having that very traceable lineage, especially because right now lineage for us, as long as we keep the input sane, then Flyte is extremely good at just keeping all the code and all the steps in between. Nice for us, and so I think were kind of the main reasons. And I did have some trust in that it works, so that definitely helped.
That's good to know. And I think it's always an interesting coming together as a team, because now you have to go exactly as Maria, as you said, you have to go back to data scientists and researchers and tell them, yes, if you want to run your Bayesian time series the classical way you have done this here, now we actually going to put this a little bit on a platform where we can all collaborate. What was the feedback from your researchers? Were they okay to say, hey, look, let's try this all, or did you have to convince them?
Yeah, I think luckily we're a small and fairly close team, and so I think you know, a lot of folks from the research end were also involved in kind of the decision making and, you know, trying out prototypes and things like that. And the reception has been really positive, especially you know, the baseline team that we've talked about a little bit has really like gone 100% all in, and you know, I think time after time they'll call out how much their productivity has improved, how much more that they can do, how many more experiments that they can run. And so yeah, they've been really fantastic with that. And then I think for other research teams too, where who might have had a bit more of their own established ways, it's been like a bit of a slower transition, but I think people are still very excited about it and kind of see the promise of it, especially as our central components have matured. Then it almost becomes a no-brainer.
That's fantastic. Absolutely great. I have one more question before we are at the top of the hour. So, you know, now that you're 2 years into it, you have teams adopting it. Looking back, I mean, hindsight, everything is 2020. But you know, if you see somebody else asking for you for the one or two pieces of advice to get their story straight and right, moving forward into a production system like what you have, what is maybe the one or two pieces of advice that you would want to give the Marie from 2 years ago?
That's really tricky.
One clarification, Murray. It's not been 2 years for you guys, right? It's
yeah,
been less than that.
Yeah, a little under a year. So I think we started evaluating in March of this year. Yeah. Yeah, I think I think we maybe avoided some of the rookie mistakes. Thanks a lot to Bernhard's experience already, and but I do think you know, I think maybe we've the rest of our team has started engaging more with the community, and you know, looking for open source help and, you know, seeing if we can make PRs here and there. And I would say maybe the advice to myself earlier would be to encourage the team like even earlier on to start doing that. Bernhard, I don't know if you also have kind of advice.
That's a tricky question. Probably the CI/CD, getting that right and getting a template right, so that the onboarding effort for a new data engineer, and then that it's a really pleasant experience also inside the company. And there is some tooling that you have to build around depending on how you do CI/CD, how you do things. I think building that and making it easy for internal stakeholders to onboard is probably the most important thing. And then also going in, helping them, and just fixing issues, because there's things that will arise. And maybe not every data engineer knows Docker as well as they need to, and yeah, so on and so forth. So just a lot of education, I think, would be the thing that I can suggest.
Yeah, absolutely. I think what we hear as a common, you know, theme is the community. I mean, people come back, and exactly Marie, as you said earlier, and Bernhard, as you alluded to, is like engaging with the community. I mean, you work closely with Dan Remmer, I think, Bernhard, and so he's super stoked about your work, and also with the people here. So I think this is something that helps you to get started and get on the track the right way, versus, you know, going down a rabbit hole potentially where you think there should be something, but there's nothing. And so I feel like that's what I hear all the time. And I feel like I want to say thanks to you, Marie and Bernhard, to the Pachama team, to your core team, to speak about Pachama and your Flyte journey. I think this is super interesting. We'll put it out on the web and social media and share it. And I would love to follow up with you when we go from the technical assessment, the assessment part of your business, to the marketplace and see what you're going to do in the marketplace. Maybe we can have you back next year and talk a little bit about what's happening there. But I just want to say thank you very much. This was super exciting to get that feedback about your company and your use case.
Yeah, thank you all so much. It really has been fantastic and a smooth experience. So we really appreciate all the work that you do.
Great, awesome.